I'm going to try something different this time. I'm going to try not building in the stops and just running it at a slow enough speed, I think, and talking my way through it. So let's try this. 1.1, the second part is planes. And so we represent a plane by a parallelogram, but we got to remember, just like lines, it really goes forever in every direction. If I picture the floor of a room, that's just a snapshot of a plane that continues. The wall, it's a snapshot of a plane that continues. We name a plane by any 3 points that are on the plane. So now we've got some points on the plane. Got X, Y, and Z. So, and A. We could name that plane lots of different things. We can name it plane A, Y, Z. Lots of other possibilities. We can call it plane AYX. Any combination of those three of those 4 letters. So that's how we can name it. But also, any 3 non-collinear points forms a plane. So 3 random points anywhere. Any 3 points that could make a triangle. A triangle is a planar figure. It's a snapshot of a plane that is invisible and continues forever. So we just don't always draw in a trapezoid to represent, parallelogram to represent the plane. And then sometimes we can take a shortcut for naming a plane, and we just use a lowercase letter. And then we just have to write plane C instead of plane AYX or plane AZY or what have you. Remember, planes are not nearly going to be as important for us as lines and segments and rays. So those are going to be your first concern. Planes are often confusing at first, but I just want to expose you to it, and as time goes on, you guys are going to be experts. So the one thing we didn't talk about yet is coplanar, right? There's not an E in the word, I just put it there for pronunciation. Coplanar. And just like collinear points are points on the same line, coplanar points are points that are on the same plane, right? So if I've got a plane, I've got some points on it, I've got a line going through it. That little dash means like it's showing through the bottom of the piece of paper, like if you shoved a pen through a piece of paper. The dash part saying you can't really see it, and actually I should doctor up that. Hold on, let's fix that up for a second. I wonder if I fix this up right now, if you'll see it. There. I wonder if that showed up now. Right, the dash part saying that's hiding behind the piece of paper, and then you can see the bottom of the pen that sticks out. So A, C, and D are coplanar. Now B is not. It's not on that same blue parallelogram piece of paper. It's up on the line. So B is not coplanar with those 3 other points. Right? Those 3 form a plane. They're on a plane. B is not on that same plane. However, we said that any 3 non-collinear points actually form a plane. It may be invisible and not drawn in. So in that case, we've got lots of sets of non-collinear points that include B, right? The only thing B is on the same line as is A. So we can form another plane that's not drawn in, and I am not a good enough artist to show you, but if you pictured a big knife coming down and chopping through B and A and C, that would be another plane, or a piece of paper shoved down through there. Same thing with any other combination of those 3 letters, right? It doesn't have to be drawn in to actually be a plane. So same thing would happen with B, C, and D, And again, also with B, A, and D. And I think I mentioned this in class. Remember, planes, think about games that you play with goals. Right? The ball has to cross the plane to go into the soccer goal or the football goal or the water polo goal. It doesn't have to go back against the back cage or etc. It just has to cross that invisible plane that the front of the cage represents.